Hi everyone, welcome to goclasses. Please tell me, is the audio video volume, is everything fine? Please tell me. Okay, so let's start now. So in this session, we will see the homework 5 solutions. Okay. So if you want to access all the homework solution from homework number 1 to basically all the TOC, theory of computation, all the homework solution, if you want to access, then link you can find in the description. Okay. So let's start now. And if you want to join, if you want to understand, if you want to study, if you want to learn TOC, theory of computation, the complete course, if you want to study, if you want to learn, then this course you can join, goclasses theory of computation course you can join, and the link you can find in the description. Okay, so all the links are in the description. If you want to prepare for the GATE computer science 2023 2024, okay, all the links are in the description. Okay, so this link of the GATE computer science complete course, this link is already available in the description. You can check it out. The link of test series, okay, GATEOverflow plus goclasses test series, and you can notice this Android app, goclasses Android app. So all these links you can find in the description. Okay, now let's study. Let's solve the questions. Let's come back to the questions. All these questions I have taken from this book. Okay, all the questions in this homework, every question is taken from this book. Okay, this problem solving in automata, languages and complexity, this book. Okay, from this book I have taken all the questions, all the GATE relevant questions I have taken. Okay, all and only the GATE relevant questions I have taken. So now let's study. Let's start one by one. So let's see this first question. Tell me what is the answer. Quickly tell me. This is an easy question. Okay, in this question we are asking, in this question I am asking that how many strings over the alphabet A1, A2, AK are there which are of length n, where n is non-negative integer. N is non-negative integer means n can be 0, 1, 2, 3 and so on. Okay, so n can be 0. Okay, anyway, so how many strings are there on this alphabet? This is your alphabet. In this alphabet you have total, in this alphabet total k symbols are there. Okay, so what is the cardinality of this alphabet? So that is your k, total k symbols are there, and I want strings. This strings I want. Okay, I want the strings of length n. We want strings of length n, total string total length we want n. Okay, so how many strings we can create? Very easy. You can notice the first position. For the first position, how many choices I have? In the first position, because I want a string of length n, this is what I want. I want the string of length n. So for every position I have k choices. Okay, for every position I have k choices, because here you can put any of these symbol, A1, A2, AK, any of these symbol I can put here. Okay, so for every position there are k choices. There are k choices for every position. For every position there are k choices. So finally, how many strings you can create? So how many number of strings of length n? So that will be number of strings of length n. What that will be? For every position you have k choices. For every position you have k choices. So the answer will be k power n. Okay, this will be the answer because total n positions are there, and for every position you have k choices. So finally your answer will be by product rule. Okay, you can apply the product rule of the combinatorics. In the combinatorics we have already seen the product rule that you can apply, and finally your answer will be k power n. Basically I can call it your alphabet cardinality power n. Okay, so the answer will be alphabet cardinality power n. This is the generalization. Okay, how many strings of length n? That answer will be alphabet cardinality power n. Okay, this will be your answer. Very simple. So this you can take as a result. Remember, you can take as a result if your alphabet, this result you can take if your alphabet is sigma. Your alphabet is sigma, or let's assume this is the cardinality of the alphabet. This is the cardinality of the alphabet. Then I can say how many strings you can create. Okay, what is the number of strings of length n? What is the number of strings of length n? That will be cardinality of sigma power n. Okay, this will be your answer. You can take this as a as a node. Okay, now let's see some variations. Let's solve these variations. Tell me what is the answer here. If your alphabet is ABCD, then how many strings of length 5 you can create? How many strings of length 5 you can create? So you can notice this is your alphabet. So that will be alphabet cardinality power 5. Okay, and that will be 4 power 5. So this will be your answer for the first question. What is the next question? How many strings of length n are there? So that will be alphabet cardinality power n, and that will be 4 power n. Okay, so your answer will be 4 power n. Next, how many strings? Next question is, how many strings of length 7 are there in which first, middle and last symbol are B? Okay, so this is your next question. Let's call it question number C. So let me call it question number C. Then you can notice length 7 we want total length 7. Okay, so we want length 7. 1, 2, 3, 4, 5, 6. So total length we want 7. 1, 2, 3, 4, 5, 6, 7. And the question is saying that the first, middle and last symbol are B. Means there is no choice here. This is already B. Remember, there is no choice here. This is B, and the middle position, that is also B. So there is no choice here. I can say here only one choice. Here only one choice, because remember here it must be B, and here also one way because it must be B, and here also one way because it must be B. Okay, but for the remaining positions, now I want strings of length 7. For the remaining positions we have 4 choices. So for here we have 4 choices. Okay, for here we have 4 choices, and for here we have 4 ways. You can put any of the alphabet. Total alphabet size is 4, A, B, C, D. So you can put any of them. So again here you have 4 ways, and again here also you have 4 ways. Okay, so finally your answer will be what? The answer will be 4 power 4. Okay, this will be your answer, because you can notice there is no choice for first, middle and last position. There is no choice. First position must be B, middle position and last position, they must be B. For the remaining position, total remaining position are 4. For every remaining position we have 4 choices. Okay, is this clear? For every remaining positions we have 4 choices, 4 choices, 4 choices and 4 choices for every remaining position. So the answer will be 4 power 4. What will be the answer for the option D? For the question number D, how many strings of length at most 5 are there? Length at most 5. Okay, so we want string of length at most 5, means okay, number of strings whose length, this is what we want number of strings. So this number of strings we want whose, okay, number of strings W whose length is at most 5. Okay, so the answer will be what here? You can notice in this question, okay, so you want length at most 5. So I can say length can be 0, or length can be 1, or length can be 2, or and so on. Length can be 5. Okay, length can be 5. So tell me how many strings of length, for example, you know the strings of length n. If you want a string of length n, then how many you can create? A string of length n. So how many you can create? W. So that you can create very easily. That will be cardinality power n. And you can notice the alphabet cardinality is 4. So the answer will be 4 power n. So here you can notice this will be 4 power 0. Okay, so this will be 1. Only one string you can create, that is empty string. Okay, only one string you can create, that is empty string. Here 4 strings you can create. Those are this string, this string, this string, this string. So these strings you can create. Here you can create 4 power 2 strings. Then you can create 4 power 3, 4 power 4, 4 power 5. Your answer will be summation of these two. Summation of all of them. Okay. So your final answer, what will be the answer? Answer will be, I can say that answer will be summation of 4 power I, where I is going from 0 to 5. Okay. This will be your answer. Is this clear to everyone? So the answer will be this, summation of 4 power I, where I is going from 0 to 5. Okay, so quite simple this question. Now let's solve this question. So this question we have already solved. The proof I have given to you. Okay, this is what we need to prove. Prove that. So this is what we need to prove, and this we have already seen in the homework 1. Yes, correct? Yes or no? So in the homework 1, we have already seen the solution in the homework 1. Okay, so this question we have already done in the homework 1. You can find the solution in the link in the description. Okay, so the video solution you can find in the description. You can just check it out. Okay, so the homework 1 we have already seen this question. Basically for any string x comma y, x y whole reverse is equal to y reverse x reverse. The proof we have already done in the homework 1. You can find out this proof, okay, this homework 1 you can find out in the description. Okay, let's see this question also we have done. This also prove that, okay, we need to prove this. So these two questions, first question is this, another question is this. These two questions also we have done already in the homework 1. These two questions already in the homework 1 we have done. You can find the homework 1 solutions in the description. Okay, in the description of this video, you can find the TOC playlist. Okay, so in the TOC playlist you can find this homework 1 solution. Okay, anyway, so these questions also we have seen. Now anyway, this is just example, you can check it out. This is not a question, this is just an example. A is given to you, B is given to you, then what will be AB? This is not a question, this is example. A is given to you, B is given to you, then what is the concatenation? Concatenation will be 0 1 0 2 1 1, okay, 0 1 0 2 and then 1 1 1 2. Okay, so your concatenation will be AB will be this. Next, okay, this is the question. This we have already seen actually, but tell me, can I say cardinality of AB? What can you say about this? Cardinality of AB. So that will be less than equal to cardinality of A, cardinality of B. Okay, this we have already seen in the homework 2. Okay, you can check the homework number 2. There we have already seen this. You can find the link in the description. This we have already seen that if you have two languages, A comma B are two languages, then here you can notice A comma B are two languages. So if A comma B are two languages, then what will be the cardinality of AB? That will be less than equal to cardinality of A, cardinality of B. Okay, this is the question. So for example, here A is this, B is this, then AB will be this one. You can notice cardinality of AB is less than equal to cardinality of A multiplied by cardinality of B. Okay, you can check it out. This is your homework 2. In the homework 2 we have already seen the proof. The proof we have seen, remember the proof we have seen in the homework number 2. Okay, next, let's see this question. This is A, this is B, then what will be AB and what will be ABA? Okay, let's see, this is a good question. So let's see this one. So you have this A is given to you. Okay, so A 0 1 power n. Okay, what is A? You can notice A 0 1 power n, 0 1 power n, where n is greater than equal to 0. And what is B? B is 0 1 0 1 0. Okay, so tell me what will be AB? You can find out what will be the concatenation of these two. The concatenation of these two will be, you can concatenate, or every string here you can concatenate with this, or every string here you can concatenate with this. Okay, so what you will get? So you will get 0 1 power n, 0 1, okay, where n is greater than equal to 0, union 0 1 power n, 0 1 0, where n is greater than equal to 0. Okay, so this is what you will get, correct? Very simple. Remember, we are doing the concatenation. So this is A, this is the language A, this is the language B. So what will be A concatenated with B? AB. What will be AB? That will be every string of A. Remember, very simple, every string of A you will concatenate with every string of B. Okay, so every string of A you will concatenate with this. Also what you will do, every string here you will concatenate with this. Okay, every string here you will concatenate with this. So this is what you will get. So your final answer will be this one. Now you can write it 0 1 power n, where n is greater than equal to 1. What you can write it? You can write it 0 1 power n, where n is greater than equal to 1. Because remember, you can write it 0 1 power n, where n is greater than equal to 1 because of this 0 1. Okay, because of this 0 1. So it will be like 0 1 power n, at least I can say n is greater than equal to 1, union. Okay, this will be what? This will be 0 1 power n followed by 0, where n is greater than equal to 1. Okay, this will be your answer. You can check it out. Okay, so your answer will be this one. Very simple. Okay, next, similarly you can find what is ABA. Okay, you can just check it out. This will be your answer. Once you have found this AB, now you need to do ABA. ABA means this AB you already have this A. Okay, so that means every string of AB you will concatenate with every string of A. Okay, this will be your answer. Remember, every string of AB you will concatenate with every string of A. So this string, every string here you will concatenate with every string here. Similarly, every string here you will concatenate with every string here. Okay, so like this you will get ABA. Okay, anyway, let's move on. Let's see the next question. Tell me about this one. Let's solve this question. Tell me, is the volume fine? Volume, audio, is everything fine? Please tell me. Audio quality, is audio quality good? Please tell me. Okay, let's solve this question. So what this question is saying, that empty string. Okay, so some true false statements are there. You tell me which statements are correct. Which statements are correct? L is a language over alphabet. Then the following, okay, then which of the following are correct? L is a language. Remember, L is a language. Language is set of strings, correct? Remember, what is alphabet? What is the difference between alphabet and language? Alphabet is set of symbols. Alphabet, what is that? Alphabet is set of symbols, atomic symbols. Okay, so this is, I can say, finite non-empty set of symbols. Okay, you can call it finite non-empty set of symbols. So this is a finite non-empty. It must be a finite set of symbols, and it must be non-empty. So what is your alphabet? Alphabet is set of symbols. But what is a symbol? What is a symbol? Symbol is every symbol is atomic entity. Symbol is atomic entity of length 1. Atomic entity. Remember, every symbol is an atomic entity of length 1. Correct? Atomic entity of length 1. Okay, very simple. So your alphabet can be like this. Your alphabet can be, for example, 0, 1. This your alphabet can be. So you can notice that every symbol is an atomic entity of length 1. You cannot break it. Okay, every symbol is an atomic entity of length 1. What is language? What is language L? Language L is, I can say, set of strings. I can say that is set of strings. It can be finite, no, okay, infinite. It is any set of strings over sigma. Okay, using this alphabet, using these symbols, whatever strings you can create. Okay, so I can say basically language is set of strings. So I can say language L is subset of sigma star. This we already know. Okay, this we already know that language is a subset of sigma star. What is sigma star? Sigma star set is set of all strings. This is set of all strings. This is important. This is set of all strings. Okay, sigma star, that is set of all strings over sigma. Using these two symbols, whatever string you can create, that is in the sigma star. Okay, using these two symbols, whatever string you can create, all the strings, collection of all the strings, that is sigma star, and every language is subset of sigma star, or I can say every subset of sigma star is a language. Now the question is asking, empty string necessarily belongs to sigma star. What about this? Empty string necessarily belongs to sigma star. Yes, this statement is correct. This statement is correct because you know that what is sigma star. How do we define? Remember, sigma star is a set of all strings. Whatever sigma you take, you can take any sigma, you can take A, B, C, whatever sigma you take, whatever alphabet you take. Remember one thing, this empty string, okay, let's assume this is the empty string. Tell me, let's assume this is the empty string. Tell me, empty string never belongs to sigma, right? Empty string never belongs to sigma, correct? Very simple. Empty string never belongs to sigma. This you already know. Okay, this we already know that empty string, because empty string is a string, please understand. Please understand, empty string is a string. So empty string lambda, okay, never belongs to sigma. Never belongs to sigma. Never belongs to alphabet. Okay, so this is the first point. Now you can notice that if this is your alphabet, then what is sigma star? Sigma star is set of all strings. Sigma star is set of all strings. Okay, sigma star is set of all strings over sigma. And you can notice, because sigma star is set of all strings, so I can say this empty string definitely belongs to sigma star. Okay, it will always belong to sigma star, correct? Because sigma star is set of all strings. And in all the strings, empty string is also there. Okay, so I can say empty string definitely belongs to sigma star. It will definitely belong to sigma star. This statement is correct. You can also think like this. What you can do? You can also think like this. Let me tell you. So you can also think like this, that what is sigma star? Sigma star is sigma power 0 union sigma power 1 union sigma power 2 union sigma power 3 and so on. Okay, what is sigma star? Sigma star is basically summation of sigma star. Sigma star is summation of sigma power n where n is greater than or equal to 0. Okay, or I can say sigma power I where I is greater than or equal to, or I can say I belongs to set of, or I can say I belongs to set of whole numbers. Okay, I belongs to set of whole numbers. This is your sigma star. And you can notice what is sigma power 0. Tell me this point. What is sigma power 0? What is sigma power 0? Tell me that. Sigma power 0 is a empty string, set containing empty string. Sigma power 0, that is set containing empty string. So you can notice there is union. We have union here. So finally I can say this will be what? I can say what will be sigma star? Sigma star will have empty string. Okay, remember this is your empty string. So sigma star will have empty string. It will have strings of length 1, like if you have ABC. If your sigma is ABC, let's assume your sigma is ABC, then you will have strings of length 0, strings of length 1. You will also have strings of length 2. Okay, strings of length 2 like this. Okay, and so on. Strings of length 3, strings of length 4, strings of length and so on. Okay, like this. What is sigma power n? That is set of all strings of length n. That is set of all strings. That is set of all strings of length n. Okay, anyway. So this is the first question. What is the second question? Empty string never belongs to sigma plus. This statement is also correct, because empty string can never belong to sigma plus. Whatever sigma you take, there is no empty string here. For example, you have AB. Now you can notice what will be sigma plus. Sigma plus is set of all non-empty strings. Okay, yes or no? So very simple. Sigma plus, that is sigma power 1 union sigma power 2 union sigma power 3 and so on. So what is sigma plus? If you notice, what is sigma plus? This is a set of all non-empty strings. Set of all non-empty strings. So empty string never belongs to sigma plus by the definition of sigma plus. What is the sigma plus? Sigma plus is a sigma power 1, sigma power 2, sigma power 3 and so on. So you can notice this is set of all 1 length strings. This is set of all 2 length strings. Remember, this is set of all 1 length strings, set of all 2 length strings, set of all 3 length string and so on. So you have set of all non-empty string, set of all non-empty string. So you can notice empty string never belongs to sigma plus. Empty string never belongs to sigma plus. Okay, so this statement is also correct. Okay, let's see these two statements. Can I say empty string necessarily belongs to L star? Tell me. Please tell me. Can I say empty string necessarily belongs to L star? This statement is correct. And let's see this statement. Empty string never belongs to L plus. Empty string never belongs to L plus. Empty string never belongs to L plus. This statement is wrong. Okay, so now let's see these two statements. Statement number 3, statement number 4. So let's see. Very simple. Let's see the statement. First of all, if L is a language, if L is any language, if L is any language, then you can notice this statement is correct, that empty string belongs to L star. L can be any language. Remember, L can be, if L is any language, it can be any language. Okay, then this statement is correct, that empty string belongs to L star. This statement is correct. But this statement is not correct, that empty string does not belong to L plus. This statement is wrong. Okay, this statement is wrong. What is the reason? Very simple reason you can notice. Take this language. Look at this language. Tell me, is this a language? A, comma, BA. Is this a language? Tell me. Please tell me, is this a language? Yes, this is set of all strings. This is set of strings, not set of all strings. This is a finite language. You can notice this is a finite language, but the point is this is a language. The point is this is a language because this is a, I can say, set of strings. This is a language. And you can notice one thing, that empty string does not belong to this language, correct? Tell me what is L star. Tell me what is L star. Remember, L star will always contain empty string. By the definition of L star, your L can be anything. L, okay, you can have any language. You can have any language any language you can take. What is L star? L star is L power 0, union L power 1, union L power 2, and so on. This is your L star. Okay, what is L star? Basically, what is L star? L star is, I can say, that is a summation of L power I, where I belongs to whole number. Okay, so you can notice this is your L star. Now, what is L power 0? This we have already seen. For any language, what is L power 0? Whatever language you take, L power 0. What is L power 0? Whatever language you take, this will be set containing empty string, correct? Set containing empty string. So finally I can say L star will always contain empty string. So empty string will always belong to L star, correct? Empty string, that will always belong to L star. Is this clear to everyone? Please understand that these two things are same. And this is also empty string. Okay, you can use this symbol also. You can use the symbol lambda. You can use the symbol epsilon. This is your empty string. These are the symbols for empty string. Okay, anyway, so you can notice that L power 0 for any language, L power 0 for any language L power 0 is set containing empty string. So that is the reason I can say that this is definitely correct. Empty string belongs to L star. Okay, this is definitely correct. Is this clear to everyone? Very simple. Now, okay, so for example here, this is your L, this is your language. What is L star? L star is L power 0, union L power 1, union L power 2, union L power 3, and so on. What is L power 0? L power 0, this is fixed. This is set containing empty string. What is L power 1? That is your A, BA. What is L power 2? What is L power 2? That will be AA, BA, BA, ABA, BAA. Okay, this will be L power 2, and so on. Okay, so you can clearly see that this empty string belongs to L star. Okay, so whatever L you take, it will always happen that because L power 0 for all L, this always happens. This we have already seen in the lectures. So you can notice for any L, for every language L, I can say. So for every language, what happens? Whatever language you take, for every language L, what happens? L power 0 is set containing empty string. Okay, so whatever language you take, it does not matter which language, whatever language you take, empty language, okay, finite language, infinite language, whatever language you take, L power 0 is set containing empty string. So this statement is correct. Now let's see, this statement is not correct. Remember this statement that empty string belongs to L plus. This statement is not correct. Tell me which statement is correct. Look at these two statements. Okay, L is a language. Let's assume L is a language. Okay, now if L is a language, then tell me which statement is correct. Empty string belongs to L plus. Is this statement correct? Empty string does not belong to L plus. Which statement is correct? Tell me which statement is correct. Empty string belongs to L plus or empty string does not belong to L plus. Which of them is correct statement? Which of them is correct? So let me tell you, this statement is wrong. This statement is also wrong. Okay, let me give you the example. For example, look at this L. Let's look at this language. This is a language, correct? Okay, this is a language. This is a language. Tell me what is L plus? What is L plus? L plus is L power 1, union L power 2, union L power 3, and so on. What is L plus? L plus is basically, that will be, okay, L power 1, that is A, L power 2, that is AA, L power 3, that is AAA, and so on. So finally, what is your L plus? L plus is A power n, where n is greater than equal to 1. Okay, this is your L plus. So now you can notice that empty string does not belong. So if your L is this, if your language is this, if your language is this one, okay, look at this. If your language is this one, you can notice for this language, you can notice empty string does not belong to L plus. Okay, for this language, when your language, remember, if your language L is this, then you can notice empty string does not belong to L plus. Okay, now let's look at this language. Okay, please see this language. Epsilon comma A. This is also a language, correct? This is also a language. Now you tell me for this language, you tell me. What will happen for this language? So for this language, what is going to happen? So again here, if you find L plus, then that will be L, okay, that will be again L power 1, union L power 2, union L power 3, and so on. Okay, what is L power 1? That will be empty string comma A. What is L power 2? That will be empty string comma A comma AA. This is your L power 2. what is L power 3, what is L power 3, and so on. Okay, like this you can create, like this you can create. So finally your L plus, that will be a power n, where n is greater than or equal to 0. So you can notice here empty string belongs to L plus. Okay, you can notice here empty string belongs to L plus, empty string belongs to L plus. But remember, for which L? When your L is this, when your L is this, empty string comma a. When your L is this, then you can notice empty string belongs to L plus. So can you see from these two examples, here empty string does not belong to L plus. In this language, for this language, empty string does not belong to L plus. For this language, empty string belongs to L plus. So can you notice these two statements are wrong? This statement, these two statements are wrong. Okay, now you tell me one thing, a very simple point I want to ask. So you tell me, when this will happen? This is my question. Okay, this is a question that I want to ask. When empty string belongs to L plus? This is my question. Please tell me what is the answer. When empty string will belong to L plus? When empty string belongs to L plus, what should happen? Remember what is L plus? Okay, when empty string belongs to L plus. And the second question is, okay, the first question is when empty string belongs to L plus, and the second question is, if empty string belongs to L, can I say it will belong to L plus? If empty string belongs to L, if empty string is already in L, can I say empty string belongs to L plus also? Tell me. Yes, this statement is correct, right? Okay, yes, this statement is correct. This statement is true, because if empty string belongs to L, if your L has empty string, if this is your L, if your L has empty string, then definitely L plus will also have empty string, because what is L plus? That is L power 1 union L power 2 and so on. So you can notice that if L has empty string, then this has empty string. If L has empty string, then I can say that L plus will also have empty string, because L has empty string. So empty string will belong here, empty string will be here also. So if L has empty string, then what will happen? If L has empty string, then empty string will belong to L power n, for all n. For all n this will happen. Okay, for all n this will happen. Correct? Yes or no? If your language contains empty string, then you can notice that empty string will belong to L power n for all n. Whatever n you take, it will always happen. So empty string will belong here. You can notice empty string will belong here also. Empty string will belong here also. Okay, whatever you take, empty string will belong. So if you take L power 3, if you take L power 4, empty string will belong to all of them. Okay, empty string will belong to L cube, empty string will belong to L power 4. So finally I can say that empty string will belong to L plus also. Okay, very simple. Is this clear? So, and the second point, when can I say, okay, this statement, tell me, is this statement true? The second statement I want to ask, if, this is my second statement, if empty string does not belong to L, if empty string does not belong to L, then tell me, if empty string does not belong to L, can I say empty string does, if empty string does not belong to L, if empty string does not belong to L, let's assume, okay, let's assume empty string does not belong to L, then can I say empty string does not belong to L plus? Empty string does not belong to L, then can I say empty string does not belong to L plus? This statement is also true. This statement is also true. If your L does not have empty string, just think about it. In L, if empty string is not there, this is your language L, and let's assume in the language L, empty string is not there. Okay, empty string is not there. Empty string is not there. So if empty string is not in L, okay, empty string is not in L, then you can notice empty string cannot be in any L power n. Okay, empty string is not in L, so empty string is not here. If empty string is not here, then empty string cannot be present in L square also. Empty string cannot be present in L power 4. Okay, so you can notice empty string cannot be here. Empty string cannot be here. Empty string cannot be here, and so on. Okay, and so on. So finally I can say empty string does not belong to L plus. Okay, empty string does not belong to L plus. So these are some simple points you can notice. So finally I can say, what is the answer for this question? When can I say empty string belongs to L plus? So you can notice the, okay, very simple conclusion. When can I say? So I can say that this statement, this is a if and only if statement. You can notice if empty string belongs to, okay, remember, so this is the final point. Final point is if empty string belongs to L, then empty string also belongs to L plus. Correct? If empty string belongs to L, then empty string also belongs to L plus. The second point, what is the second point? If empty string does not belong to L, then empty string does not belong to L plus. Okay, these two things we have already proven. From these two I can say, okay, from these two what I can say? I can say that empty string belongs to L if and only if empty string belongs to L plus. Okay, so this is a if and only if statement. Empty string belongs to L if and only if empty string belongs to L plus, or I can say empty string does not belong to L if and only if empty string does not belong to L plus. This is a if and only if statement. Is this clear? Tell me, all these points, are they clear? Okay, so very simple. So these are the conclusions. So what are the conclusions? You can notice that here, if sigma is the alphabet, if sigma is the alphabet, and let's assume L is the language, then some conclusions I can say. Then what I can say? Then some conclusions. First of all, empty string never belongs to sigma. Empty string never belongs to the alphabet. Okay. The second point is empty string always belongs to sigma star. And the third point is empty string never belongs to sigma plus. Okay, so these are the points. The second point you can notice, this statement is wrong. Empty string belongs to L. This statement is also wrong. Okay, this statement is also wrong. Empty string does not belong to L. This statement is also wrong. Empty string belongs to L star. This statement is correct. Okay, next, empty string belongs to L plus. This statement is wrong. And empty string does not belong to L plus. This statement is also wrong. Okay, so did you understand? Please tell me. So it will depend on L. So this is the idea. Okay, if empty string belongs to L, then empty string belongs to L plus. If empty string does not belong to L, then empty string does not belong to L plus. So this is a if and only if statement. You can notice this is a if and only if statement, that if empty string belongs to L, if and only if empty string belongs to L plus. So you can notice finally these two statements are wrong. Okay, that will depend on the language L. So this was your question. So tell me, is this question clear to everyone? The question number 5. So I can say answer will, so these first three statements are true and the last statement is false. Tell me, is this clear to everyone? Please tell me. Is it clear? Let me know. Okay, let's see this question. What is the answer for this question? We have already seen. What is the answer for this question? Can I say sigma star minus empty string is sigma plus? From sigma star, if you remove empty string, can I say it is sigma plus? Yes, this statement is correct, right? This statement is correct. From sigma star, if you remove empty string, then you will get this sigma plus. Okay, now you tell me, is this statement correct? From L star, if I remove empty string, will I get L plus? From L star, if I remove empty string, will I get L plus? This statement is wrong. We have already seen. For example, take this language. Okay, take this language. Now tell me, what is L star? For this language, what is L star? If your language is this, set containing empty string, you can notice this is a language. If your language is this, then what is the L star? L star will also be this. Okay, L star will also be this. Now you tell me, what is L plus? L plus also will be this. Okay, L star will also this. L plus will also be this. You can notice this statement is wrong, because now you tell me, from L star, if I remove set containing empty string, then what I will get? Tell me. This is your L star. from L star, if I remove set containing empty string, what I will get? This is your L star. L star is this. From this, if I remove set containing empty string, what I will get? I will get phi. But this is not equal to L plus. Can you notice this? This phi is not equal to L plus. Yes or no? Can you notice this is not equal to L plus? So this statement is wrong. Okay, from L star, if you remove empty string, you will get L plus. This statement is wrong. When this statement will be true? When this statement will be true? You know that empty string belongs to L if and only if empty string belongs to L plus. Okay, so this you already know. And you also know that empty string always belongs to L star. This also you know. Now tell me when it will happen. When it will happen, tell me. When this will be true, that from L star, if you remove empty string, you will get L plus. When this will be true? When this will be true? When does this happen? This is my question. Very simple question. When will this happen? From L star, you remove empty string, you will get L plus. When this will happen? This will happen when empty string does not belong to L, right? Okay, if and only if. This is if and only if. Again, this is if and only if. This will happen when empty string does not belong to L. If empty string does not belong to L, then this will definitely happen, correct? You can notice, if empty string does not belong to L, if empty string does not belong to L, then you can notice that L plus is actually L star minus empty string. From L star, you remove the empty string, that will be your L plus. Okay, but you can notice if empty string belongs to L, then this is wrong. Then L plus is not equal to L star minus empty string. Is this clear? So if empty string does not belong to L, this will happen. If empty string belongs to L, this will happen. So finally I can say that this is what I can say. I can say L plus is equal to L star minus empty string if and only if empty string does not belong to L. Please tell me, is this point clear to everyone? Is this question clear? Please tell me. The question number 6, which of the following is or are correct? Which of the following is or are correct? Is this statement clear? Tell me. Let me give you two more variations. Two more variations let me give you. Okay, let's try these variations. Let's try these variations. Now you have the complete knowledge. Okay, now let's try these variations. Can I say sigma star is equal to sigma plus union empty string? The second question, can I say L star is equal to L plus union empty string? Tell me, which of these statements are correct? This is the true false question. You have to find out, is it true or false? Tell me, can I say sigma star is equal to sigma plus union empty string? Yes, this statement is correct. And what about this? L star is equal to L plus union empty string. Of course, this statement is also correct. Both the statements are correct because what is L star? L star is basically L power 0 union L plus. Correct? Yes or no? Yes or no? By the definition of L star, tell me, what is the definition of L star? Definition of L star is L power 0 union L plus. And what is L power 0? That is your set containing empty string. That is the set containing empty string. So you can notice this statement is correct. Similarly, what is sigma star? That is sigma power 0 union sigma power sigma plus. Okay, and what is sigma power 0? That we already know, that is set containing empty string. That is set containing empty string. Yes or no? So both the statements are true. Very good. Alap, very good. Alap Sundaran, very good. Excellent. Okay, so both the statements are true. Okay. Now let's see this question. Is this statement true or false? Please tell me. A star is same as A plus if and only if empty string belongs to A. Here A is the language. Let's assume A is some language. Let's assume A is some language. Is this statement true? Please tell me. Just think about it. Can I say, basically this statement, can I say that L plus and L star, when they will be same, L plus and L star, when they will be same? They will be same if and only if empty string belongs to L. Empty string belongs to L, correct? This we have already seen. Because when empty string belongs to L, this will happen. Okay, so when this happens, then this will happen. And when this happens, then this will happen. Okay, so this is correct. Yes or no? Please tell me. All these variations, all these are variations. So tell me, what about this one? Okay, sigma star is same as sigma plus. Can it happen? Tell me, can it happen? Sigma star is same as L plus, sigma plus. It can never happen, right? It can never happen. It is never possible. Correct? Yes or no? It is never possible. It is never possible. This is never possible. But remember, if you can notice, if empty string belongs to L, then you can notice that empty string also belongs to L plus. So I can say, so in this situation, empty string also belongs to L plus. So in this situation, I can say that L plus is same as L star. Okay, in this situation, I can say L plus is same as L star. And the same thing will happen. If this happens, then this will happen. Okay, L plus is same as L star. So if this happens, then this will happen. Okay, so this is if and only if statement. Is this clear? So I can say that L plus is not same as L star. If and only if L plus is not same as L star. If and only if empty string does not belong to L. Correct? Yes or no? Empty string does not belong to L. Similarly, I can say L plus and L star, they are same if and only if empty string belongs to L. I hope all these points are clear. And similarly, you can notice that L plus is equal to L star minus empty string if and only if empty string does not belong to L. Okay, so all these are variations. Please tell me. Please tell me. All these are variations. Yes or no? Simple variations. Okay, let's see the next. What about this one? Please tell me. Find the necessary and sufficient conditions for this. The question is asking, find the necessary and sufficient condition. You have to find the necessary and sufficient condition. L is a language. Already it is given to you. It is given L is a language over this alphabet A, B. X is a string. It means X is a string. Okay, it means X is a string. A is a language. This is a language. You can notice this is a language. Now the question is asking, and X is a string. The question is asking, what is the necessary and sufficient condition for this? What is the necessary and sufficient condition for this? See, here in this question you can notice X belongs to AB star. Okay. In this question, if I ask you what is the, okay, let me change the question little bit. If I say that X is empty string, if I say X is empty string, if I say X is empty string, if I say X is empty string, now what will be the answer? A is a language, and if I say X is an empty string, now what will be the answer? Now tell me what will be the answer. If I say that X is an empty string, in this situation, okay, this will happen if and only if, empty X does not belong to A, correct? If and only if X does not belong to A. Yes or no? Is this clear? Tell me, is this point clear? If I ask you that X is an empty string, my question is very simple. X is an empty string. Okay. So if X is empty string, then I can say this will happen if and only if X does not belong to A. Now the question is different. Now the question is actually different. X is any string. Please understand, X is any string. Okay, please understand, x can be any string. X can be any string. X need not be empty string. X can be any string. Now the question is asking, what is the necessary and sufficient condition that a star minus x will give you a plus? Now tell me the answer. Now you can very easily see that, okay, very simple. You understand what is L star? L star, the only difference is L power 0. Correct or not? Do you agree that the only difference is this? See, the only difference is this. This is the only difference. Or I can say like this. L star is basically L power 0, union L power 1, union L power 2, and so on. And what is L plus? What is L plus? L plus is L power 1, union L power 2, and so on. So the only difference is this. This is the only difference between these two. Between these two, the only string that can be different is this. Please tell me, did you understand? Remember, this x can be any string. This x can be any string. Okay, now you can notice that the only difference between L comma L star, okay, that can be L plus comma L star. Maximum what can be different? Which string? Okay, if they are different, then which string, they are different in which terms? Just tell me this point. If they are different, then only which string can make them different? Just tell me this point. If these two are different, then which string can make them different? Okay, then which string can make them different? Then which string can then which string can make them different? So the only string, okay, which string can make them different? The only string, the answer is empty string. The answer is empty string. Only empty string can make them different. This is the only string which has the capability to make them different. No other string. Now the question is saying that, okay, now the question is saying that a star minus x is equal to a plus. Okay, is equal to a plus. Then what is this string? Then, okay, this can happen if and only if, what can happen? This can happen if and only if x is empty string. Okay, if and only if x is empty string, and remember, if and only if x is empty string and it does not belong to a, and x does not belong to a. Please tell me, did you understand this? A very simple question. A plus and a star, the only difference can be empty string. Very simple question. This is the question. Read the question. Very nice question. You can notice x is a string. We don't know what is this string. X is a string. X is a string. L is a language. Okay. Now the question is asking, find the necessary and sufficient condition such that this will happen. This equation will happen. This equation will happen. So you can notice that the only string. Look at L plus and L star. Look at L plus. Look at L star. The only difference is L power 0. And what is L power 0? That is set containing empty string. So this is the only string that can make them different. If they are different, then this is the only string which can make them different. So finally I can say, okay, this L can be any language. It can be any language. Then what we can say? We can say that L star minus x. Okay, or x is some string. X is some string. We don't know what is this string, but x is some string. Now we can say that L star minus x equal to L plus if and only if x must be empty string, if and only if x must be empty string and x does not belong to L, and x does not belong to L. So this is the sufficient and necessary condition. Please tell me, did you understand this? This is the necessary and sufficient condition. Okay, so x must be empty string and you can notice x should not belong to L. Is this clear? This is the question. Please tell me yes or no. Is this question clear? The question is asking what is the necessary and sufficient condition for this equation. For this equation, what is the necessary and sufficient condition? So the answer will be x must be an empty string and x does not belong to A. And what about this question? Let me ask you one variation. So can we create a variation? Let's create this variation. Let's create a variation now. So let's assume again this L is a language. Let's assume L is a language, or maybe you can take A. Maybe you can take A. A is a language. Now the question is, X is a string. X is a string. X is some string. Okay, now my question is this. What is the necessary? Find necessary and sufficient condition for this. Find necessary and sufficient condition for A star equal to A plus, find necessary and sufficient condition for this. A plus is not equal to A star minus X. Find necessary and sufficient condition for this one. Tell me. Okay, find the necessary and sufficient condition for this one, that A plus is equal to A star. A plus is not same as A star minus X. A plus is not same as so actually here, okay, here actually X can be anything. Okay, no, this question does not make any sense. This question does not make any sense. What is the reason? This question does not make any sense. Okay, actually. Anyway, tell me when it will happen. Find the necessary and sufficient condition for this. For this, you find the necessary and sufficient condition. A plus is not equal to, A plus is not equal to A star minus X. Here X can be, if you notice, here X can be any string of A plus, right? Please understand what will be the answer for this question. The answer will be, here X can be any string of A plus. Here X can be any string, either X belongs to A plus. Either X belongs to A plus, right? Yes or no? If X belongs to A plus, if X already belongs to A plus, then what you are doing? Then from A star, you are removing this X, so it will not be same as A plus. Or what can happen? Or what can happen? So either X belongs to A plus, or what can happen? Or what can happen? Or it can happen that this X is, or it can happen that this X is empty string, or X is empty string and X belongs to A. Only these two can happen. Please see. Either this will happen or this will happen. Is this clear to everyone? Please tell me. Did you understand this one? Either X belongs to A plus, or X belongs to, or X is lambda and X belongs to A. Okay? Please tell me, is this clear? So this is a variation, and I am asking what is the, if this is true, A plus is not equal to A star minus X, X is some string, then what will be the necessary and sufficient condition? This will happen. Is this clear? Anyone has any doubt in this? Please tell me. Look at this. Okay, let's look at this. Let's assume A is this. See, if A is this, let's assume A is A. Let's assume A is A. Then what is A plus? A plus is A power n, where n is greater than equal to 1. What is A star? A star is A power n, n is greater than equal to 0. Now you can notice, if I take X equal to, for example, 4A. If I take X equal to 4A, then this will happen, right? Then what will happen? If I take X equal to 4A, then you can notice A plus is not same as A star minus X. Do you agree or not? Please tell me. If X belongs to A plus, if X is 4A, then this will happen, correct? Similarly, you can notice if X belongs to A plus, if x belongs to a plus, then you can notice that this will definitely happen. And you can also see that if, okay, let's assume your a is this, then your a plus also will be this, your a star will also be this. Then you can notice this statement, look at this statement, a plus is equal to a star minus x. Okay, so clearly you can notice here you can clearly see if here x is an empty string. Okay, this is not same as this. Why this is happening? Because you can notice if I take x equal to empty string, then, and you can notice that this empty string does not belong to a. Sorry, empty string belongs to a. So because of these two, what will happen? This will happen. Okay, so these are two variations. Let me just conclude the variations. So you can notice if a is a language, this is the conclusion. Okay, let's assume a is any language. It can be any language. I don't know what is this language. It can be any language. Remember, this a can be any language. And let's assume x is some string. I don't know what is string, but x is some string. Then you can notice this will happen. A plus is same as a star minus x. If and only if. When it will happen, tell me. When it will happen, if and only if, I can say if and only if x is empty string and empty string does not belong to, x is empty string and empty string does not belong to a. Is this clear? Please tell me. These are small tricky questions, but these are nice questions. And this, what is the if and only if condition for this? If, okay, this does not happen, this a plus is not same as a star minus x, then what will happen? If and only if, I can say x does not belong to either x belongs to a plus, or see, if x belongs to a plus, then this will happen. Then definitely I can say you are removing this this x you are removing from a star, so definitely this is not equal. Or what can happen? Or it can happen, either this can happen, okay, or this can happen, that x is empty string and empty string does not belong to a. Empty string belongs to a. Okay, so this is the conclusion. I hope this whole thing is clear. Please tell me, is the whole thing clear? Let me know. These are some tricky questions. Yes or no? Okay, let's see this. This is a simple question, very simple question. So a is a language, grand empty string. So this a is a language. Maybe alphabet can be, maybe what can be alphabet? Tell me. Look at these two languages. Let's look at these two languages. Then what can be alphabet? What do you think? What is the alphabet? So alphabet can be English alphabet, correct? Alphabet can be English alphabet. Okay, alphabet can be English alphabet, right? Now what is AB? So AB is very simple. AB will be what? That will be every string of A concatenate with every string of B. Every string of A concatenate with every string of B. Okay, remember, every string of A concatenate with every string of B. Every string of A concatenate with every string of B. So this will be your AB, correct? Okay. Next, what is your A star B? What is the A star B? A star, remember, A star means it is basically any sequence of strings of A. First of all, you find A star. Before finding A star B, first you find what is A star. Can anyone tell me what is A star? What is A star? Can anyone tell me? You can check it. A star is grand power n, okay, where n is greater than equal to 0. This is A star. So what is A star B? Okay, A star will be grand power n where n is greater than equal to 0. So what is A star B? A star B will be grand power n and followed by these. Now you can easily find, correct? Okay, now you can easily find, yes or no? So this is an easy question, you can check it out. Very easy question. So what will be your A star B? That will be grand power n followed by grandmother, grand power n followed by grandfather, grand power n followed by mother, grand power n followed by father. Okay, so this will be your A star B. Now let's see the next question. Tell me this. This is also easy question. Tell me, what is the shortest string over alphabet 0? What is the shortest string over alphabet 0 which is not in this? Okay, so this is your language. You can see your language is this empty string 0, 0, 0 and 0 power 5. This is your, and the question is asking what is the shortest string which is not in L power 3. So find the shortest W. So find the shortest W such that W does not belong to L power 3. So tell me what that will be. In L power 3, what you have? Okay, let's start, because we want shortest, so let's start with the smallest. Okay, because we want this, we want, correct? Okay, so you can notice L power 3, what that will be? L power 3 will definitely have empty string. This we have already seen, this result. Do you remember this result? Okay, do you remember this result that if empty string belongs to L, then what will happen? Then empty string belongs to L power n for all n, correct? Yes or no? Then empty string belongs to for all n. For all n, correct? This we have already seen. If empty string belongs to L, then empty string will belong to L power n for all n. Okay, for all n. And similarly, this is the, I can say this is two-way direction. So I can say this is actually two-way direction. Anyway, so this is two-way. Okay, let's see the next. So here you can notice the empty string will be there. Okay, will 0 be there? Yes, 0 will be there. Double 0 also will be there. Okay, so in L cube you will have 0. You will have because of this epsilon you will have double 0. Okay, can you have triple 0? Yes, that also you can have. Triple 0 also you can have. Can you have 4 0? That also you can have. Can you have 5? Okay, that also you can have. Can you have 6? That also you can have. Can you have 7? Tell me, can you have 7? Can you have 0 power 7? In L power 3, can you have 0 power 7? See, we can have, in L power 3, we can have epsilon. Okay, for epsilon, you will do epsilon, epsilon, epsilon. For 0, what you will do? For 0, you will do 0, epsilon, epsilon. Okay, for double 0, what you will do? For double 0, what you will do? You will do 0 dot 0 dot epsilon. For triple 0, what you can do? You can do 0 dot 0 dot 0. Okay, so 0 power 4 also you can create. 0 power 4, how will you create? 0 dot 0 dot 0. So like 0 power 4 you can create. 0 power 5 also you can create. 0 power 5 you can create 0. Okay, like this you can create 0 power 5. 0 power 6 also you can create 0 0 dot 0 0 dot 0 0. Now tell me, can you create 0 power 7? Yes, I can create 0 power 7. Okay, like this I can create 0 power 7. Okay, next, can I create 0 power 8? Can I create 0 power 8? What about 0 power 8? So our language is this. Your language is empty string 0 0 0 and 0 power 5. This is your okay, so can you create 0 power 8? Yes, 0 power 8 also you can create. 0 power 8, that will be 0 power 5 dot 0 dot 0. 0 power 9, yes, I can create 0 power 5 dot 0 dot, okay, 0 0. So like this. What about 0 power 10? You can create. 0 power 10 also you can create. 0 power 11. What about 0 power 11? That also you can create. 0 power 11 also you can create. 0 power 12. What about 0 power 12? That also you can create. 0 power 13. Okay, 0 power 13. What about 0 power 13? If I want to create 0 power 13, then I need to take 0 power 5. I need to take 0 power 5, 0 power 5. Now I cannot create, right? Okay, now I cannot create. So this is the smallest string. This is your answer. Is this clear to everyone? Please tell me. Nice question, right? Okay, like this is a simple question, but this is nice question. You can notice here you can create like this 0. Okay, like this you can create this 0 power 5, 0 power 5 dot 0, 0 power 5, 0 power 5, 0 power 2. So 0 power 13 you cannot create. So your answer will be 0 power 13. So for this question, the answer will be, what will be the answer? Answer will be 0 power 13. Is this clear? Let me know. Now this is the last question. Before we see this last question, at this point of time, please tell me, did you understand all the questions? At this point of time, did you understand all the questions? This question, did you understand? This question. See, this question, did you understand? Please tell me, this question, did you understand? Before we see the last question, please tell me, at this point of time, please tell me, did you understand everything? This question and all the variations that I have taken. Some questions I have taken, some variations I have taken. Okay, I have told you all the details. So, did you understand everything right now at this point? Okay, all the variations and everything. Okay, so let's see. So if you understand everything, okay, if you understood everything, then a small thing I want to tell you. So, okay. So anyway, so all these questions, these are standard questions. We are taking all these questions from the standard resources. Okay, like homework 1, we have taken Peter Lynch questions, Peter Lynch exercise questions we have taken. In homework 2, we have taken Boston University questions. Homework 3 is from the, you can check it out. Homework 3 is from the Dexter Cogen book. Homework 4 is also from the Dexter Cogen book. Okay, so I think homework 3 is from IIT Bombay assignment. Anyway, you can check all the homeworks, all the homework that we give to you. Okay, these are from many standard resources. Okay, so all these are standard questions. All these are very nice, GATE relevant standard questions. These questions will improve your knowledge a lot. Okay, these questions, they are, I can say, these are easy also, and these are tricky also. You should take care. You have to apply your brain. You have to do the analysis. Okay, so anyway, also I request you that if you think that okay, all these questions, these are standard questions, all these are quality questions. Okay, so and these questions should reach more students. So help us and like and comment. Okay, so these like, comment, share, of course. Okay, so everyone says that. Okay, so I am also saying that. So you like, comment, share with all the GATE aspirants. Okay, or share with anyone who is learning theory of computation. Okay, whether you are in semester or you are doing BTech exam, whatever. Okay, so share with everyone who wants to learn theory of computation, or share with all the GATE aspirants, GATE computer science aspirants, share with all of them. Okay, and please like. Okay, so press the like button before the last question. Can you press the like button? Okay, so like, share and comment. Okay, so when you comment, then automatically YouTube will recommend this video to more students. Okay, so when you comment, so please comment on the videos whenever you watch any Go Classes YouTube video. Okay, if you like, because in every video you will find some very interesting content. Okay, in every video you will find very nice content from the standard resources, very quality content you will find. So whenever you like a video, okay, and you think, oh, this is a nice video, then you like. Okay, please understand, you like, you comment, because comment is very important for the YouTube algorithm. If you comment on the video, then YouTube will recommend the video to many students, to more students. Okay, so like, comment and share. Okay, anyway, so let's see the last question. And all the links you can find in the description. If you want to join theory of computation, if you want to join GATE Computer Science complete course, or if you want to study Theory of Computation complete course, all these things, all the links are in the description. You can join our Telegram channel also, Telegram group. For doubt discussion, you can join our Telegram group, and the link of GoClasses Telegram group is in the description. Okay, in the description you will find all the links. The link of Android app, GoClasses Android app, okay, the link of GoClasses website, the link of GoClasses test series, okay, Telegram group for doubt discussion. Also, all these links are already available in the description, so you can check out the description. Okay, thank you. Now let's see. So let's see this last question, and this is a new variation. This is a new type of question. So let's see this. What the question is saying. This equation is given to you, and the question is asking which strings will satisfy this equation. So there is an equation, and the question is asking which strings will satisfy this equation. So this is a new question. This is a new nice type of question. Let's see this. Let's solve this. So solve the word equation. This equation is given to you x011 equal to 011x over the alphabet 01. Find the set of strings which will satisfy this equation. Okay. So this is the question. Now let's solve this question. What the question is saying? The question is saying find all x. Find strings x. Okay, such that this will happen. Such that this will happen. Like I can say x001, x011 is equal to 011x. So for which strings this will happen? Take it. Okay, let's see this. This is a very nice question. Find all the strings x. All the strings x. Not one. Find set of strings. Find all strings x. Such that this will happen. Such that this will happen. First to tell me this point. First to tell me this point. Will this string satisfy? Will this string satisfy this equation? Will this string satisfy this equation? Let's call it equation number 1. This string, will it satisfy this equation? Will it satisfy this equation? 101, 011. Okay, 101. So will it satisfy this equation? Definitely no. Okay, so this is not then the answer. Okay, so I can say, okay, this is invalid. Is this clear? So this will not satisfy. So we want to find all the strings which will satisfy this equation. Okay, can you make some observations? What is the first observation? What is your observation number 1? What is coming to your mind? What is the first point that will come to your mind? Tell me. What will be the first point that will come to your mind? Tell me. Yes, empty string will accept. Okay, empty string. Okay, you can notice x can be empty string. Empty string will satisfy. So this is the observation number 1. That empty string will satisfy. What is the observation number 2? What is the observation number 2? What is the observation number 2? Empty string will satisfy. Tell me, what is the observation number 2? See, one thing you can notice. If x is not empty string, if x is not empty string, remember empty string will satisfy, but if x is not empty string, then you can notice. Tell me, what should be prefix of, what can you say about suffix of x? Can I say suffix of x must be 011? Can I say suffix of x must be 011? Can I say suffix of x must be 011? Please see, very simple. This is your x. Okay, very simple point. This is your x. And then you have 011. This is equal to 011 followed by x. Now can you notice that? This should be the suffix. Do you agree this should be the suffix 011? This should be the suffix. And can you notice this should be the prefix of x also? Can you notice this should be prefix of x also? Prefix of x also must be 011. Yes or no? Please tell me. Did you understand this? All these points, all these small observations. Okay, so you can, these are the some observations. Now you can notice that. Now you can solve the question. Now let's solve the question. So it is guaranteed. If this is happening, then you can notice if this is happening, then then either x is empty string. Then either x is empty string, correct? Or if x is not empty string, then you can notice x must have suffix 011. Can I say x must have suffix 011? Do you agree? X must have suffix 011. Tell me, do you agree? That x must have suffix 011, correct? Because suffix of x must be 011. You can solve in terms of prefix also, no problem. The same question you can also solve in the terms of prefix. But anyway, you can solve like this. Then x will be y011 for some string y. For some y. Okay, so now you write this in this equation. So now x is equal to, so you can notice x is equal to y011. Now you put this in this equation. Okay, so this one you put here. So what you will get? You will get y011 is equal to 011 y011. Okay, now can you cancel? Okay, so I can cancel them. Again, can I do this? I can cancel this, I can cancel this. I can cancel this, I can cancel this. Correct? Okay, so these two I can cancel. Now finally, okay, so finally what we got? Now I got this equation 011y. See, okay, x is equal to, sorry for that. So there is some mistake here. So it will be like this, x equal to y011 011. Okay, so now you can notice this you can cancel. This you can cancel, correct? So this you can cancel with this. Okay, now what will happen, tell me? Now this equation you got. What equation you got? You got this equation that y011. Can you notice from where you started you got there? Can you notice? You started and you got again there. You started here and then again you got back here. Tell me. Can you notice both are same? Yes or no? You started here and you got here. Please tell me. Is this clear? You started here and you got here. If I do the same thing again, like I started here 011x. I started here. You know, one solution is what? Tell me here what solution I got. Immediately which solution I got? Tell me immediately which solution I got. Immediately. I got this solution. I got this solution. Or I got this solution. I got this solution. Also I got this solution. These two solutions I got, correct? Please tell me yes or no. So from this equation I got these two solutions. Now you can notice from this I got this one y011. What I got? I got this one y011 equal to 011y. Now again the same thing will happen again. Do you agree or not? Again here what I will get? Again here y empty string will satisfy. Again y string, okay, it will satisfy or what will happen? Or y equal to 011z. Please tell me, do you understand this? Yes or no? Again the same story will repeat. Again the same story will repeat in terms of y. Here in terms of x, here in terms of y, the same story will repeat in terms of y. So I can say y equal to empty string will satisfy. Y equal to 011z also will satisfy. Y should have prefix, y should have suffix 011, correct? Yes or no? Please tell me, did you understand this? Here you can notice x should have suffix 011. Here I can say y should have suffix 011. Y should have suffix 011. The same story will repeat. The same story will repeat. What I will get here? I will get yz 011z. Again the same story will repeat. What will happen? I can say either z will be empty string or z should have 011 suffix. 011 suffix. Can you notice this same story will go? Please tell me. Please tell me, did you get it? So what are the, we want x, but what we want? We want x. We want x. So what is the answer? Either x is empty string or x is a y011. Again you can put y equal to empty string. Again you can put y equal to empty string, so you will get 011. So okay, so these are the answers. You can notice this is the answer, this is the answer. We want x. What is the another answer you got? What is the another answer you got? So y equal to empty string, or you can say y equal to 011, 011. This z also you can put empty string. This z also you can put a empty string. So you got 011 whole square. And so on. If you do like this, then can I say the final conclusion is x equal to 011 whole star. Please tell me, did you understand this? A simple question, but a new type of question. In the GATE exam, this question has not come so far. Yes or no? In the GATE exam, so far this type of question has not come. Okay, so far this type of question has not come in the GATE exam. Is this clear? This type of question has not come in the GATE exam so far, but the very simple question, a new type of question, a very nice question. So your answer will be what? So I can say this is your equation, x011 equal to 011x. Then from here I can say that x equal to 011 whole star. This will be your answer. Okay? Is this clear? This is a new type of question in the GATE exam has not come. So far in the GATE exam, they did not ask this type of question, this variation of question. So this is a nice question. Did you understand this explanation? Please tell me. Please tell me, did you understand this explanation? This complete explanation, did you understand? Okay. So very simple. Like this you can do. Some observations you need to make. Okay. Very simple observations you need to make. Like these are the observations you can make, like either x is equal to empty string. This is the observation number 1. X is equal to empty string. Or x is equal, if x is not empty string, then x should have suffix 011. X should have prefix 011. Okay, so like this you can say, I can say that if x should have suffix 011, so I can say x is equal to, and this is your suffix. This is your suffix. Okay, so these are questions, and I hope all the things are done. Okay, so these are the questions. Anyway, at the end, if you have any doubt, let me know. Did you understand all the questions? Please tell me. 11 questions and some variations. Total almost 15-20 questions we have done, including the variations. 11 questions and some variations we have done. Please tell me, did you understand all the things, all the concepts, all the questions, everything? Did you understand? Okay, anyway, so if you are preparing for the GATE Computer Science, then you can join goclass. GATE Computer Science complete course you can join. Let me tell you why this course is different from other courses. This one thing, let me tell you. Like you might be thinking that okay, there are many courses. Of course, there are many courses, but why this course is different from all other courses? You will see. The reason is this: in this course there is no rote learning. You will not by heart anything in this course. Okay, in this course you will never by heart formula, table, decidability table, some formula, some closure properties. Okay, so these things you will never by heart. Okay, you will understand decidability. You will understand decidability, undecidability, pumping lemma, Mahil-Nerod theorem. Okay, push down automata, closure property, whatever question is there, whatever concept is there, you will understand. You will never by heart. Okay, in any subject. Whatever subject you take, discrete mathematics, theory of computation, computer organization, computer network, digital logic, okay, dbms. So whatever subject you take, operating system, any subject you take, in all the subjects, everything you will understand. Okay, everything you will understand with proof, in depth, with variations. Okay, so there is no rote learning in this course. This is very important. Okay, this makes this course different from all other courses, because you will never by heart any theorem, formula, table, okay, results. You will never by heart these things. Okay, just understand everything and solve all the questions. Okay, and of course there are daily homework, there are homeworks, there are practice sets, there are weekly quizzes. Okay, there will be summary lectures. Okay, summary lectures will be there very soon. From the November month, there will be summary lecture of everything. Okay, GATE computer science questions, previous year GATE computer science questions, video solutions will be there for the GATE questions. Also revision session, practice session, so many things are there basically. Okay, so all these things make this course very special. Okay, in this course you will understand the concepts, you will never by heart the concepts. Okay, everything that you will study with proof. Okay, you will study with proof, you will study with proof, you will never by heart anything. Okay, anyway, so this is our GoClasses Android app, link you can find in the description. You can download this app. Okay, and next, this is test series. Okay, in this test series there are 15 mock tests and there are more than 100 quality tests. Okay, the reputation of GoClasses and GATEOverflow, that reputation is the quality. Okay, this is the reputation. This is the reputation of GATEOverflow and GoClasses, quality. So you will find quality questions. There is no ambiguous question, there is no ill-framed question. You will have quality questions with detailed solution. Okay, so this is the GATEOverflow plus GoClasses test series. More than 100 tests are there and 15 mock tests are there. For all these mock tests, there will be video solution. We will discuss the mock test in the live session. Okay, the solution of mock test, all the 15 mock tests, the solutions we will discuss in the live classes. Okay, but these live classes will be only available to those students who enroll for this test series. Okay, so those students who take this test series, they will be able to join these live classes. For the mock test, all the mock test video solutions, live sessions will be there. Okay, we will discuss every question, all the 65 questions in every test we will discuss in the live sessions. Okay, and so these things you can check. All the links you can find in the description. Okay, and discrete mathematics, complete discrete mathematics and complete C programming courses are freely available for all the learners. Okay, so you can visit GoClasses website and you can study complete discrete mathematics, you can study complete C programming, you can study everything. Complete means all the video lectures, homework, weekly quizzes, everything is there. Okay, so you can study complete discrete mathematics, complete C programming, you can study from the GoClasses. Okay, and you can join our Telegram group, link you can find in the description. So Telegram group for doubt discussion. Okay, this GATEOverflow Telegram group also you can join. GATEOverflow doubt discussion Telegram group, link is in the description. Okay, so you can check all the descriptions, you can check. Okay, anyway, so thank you everyone. So now, so after some time we will see now the okay, what we are going to see now. Okay, so after 20 minutes we will start homework 6 solutions. Okay, homework number 6. So homework number 6 solution we will start after 20 minutes, 15 or 20 minutes. Okay, is that fine? Okay, so after 20 minutes homework number 6 solutions we will study. Okay, thank you everyone.